Hello friends, I'm Nitin and with me is Dhananjay who is right behind this camera, and we are working on this topic called applications of IoT, and today we are going to speak about one of the applications of IoT in modern engineering. There are millions of applications of IoT and it was really hard to pick one, but we have chosen one of them, and it's called structural health monitoring. So what is structural health monitoring? Structural health monitoring is basically maintenance and management of structures. Structures are basically constructions such as bridges, roads, or even buildings. As civil engineering has progressed really fast in the recent days, we see many huge structures, mega structures built, and it's really difficult to manage them. So one of the current methods are that people usually go there and the structural engineers go there and see the structure and measure some of the parameters, and then they monitor the bridge or any kind of structure. But what we can do is that the development of IoT can help us in improving this and maintaining and managing these structures more efficiently. So today we are going to study about one of these applications from a perspective of computer science engineer or embedded system engineer, and we are going to see the architecture, how the data flow and the control happens, and how we can implement this using the current technology that we have. That's what we call as Internet of Things.
The world is full of stationary structures such as buildings, bridges, and dams. Any damage to them might be life-threatening and might cost heavy. Therefore, it is necessary to detect any signs of damage to these structures very early. We can define structural health monitoring as an abstract condition for these physical structures. The data measured is used to monitor physical quantities. Computer models are used to analyze this data and identify the current state of the structures and trigger alerts if any abnormality is detected. Structural health monitoring is important throughout the lifetime of the structure. We will see how necessary and useful it is to monitor the structural designs. To give a rough view of how costly it is when a structure fails, Interstate Bridge in Minnesota, USA, I-35W, has resulted in a total economic loss of over $200 million when it collapsed. This could have been avoided if structure was monitored regularly. SHM or structural health monitoring is not only useful for maintenance after the structures are built. It is also useful to validate the structural designs and characterize the performance, to monitor and control the construction process, and to design appropriate retrofit measures. What are the traditional ways to monitor structures? Structures can be manually inspected every now and then, but this method is more prone to human errors. Next is sensors attached to the structures will be connected to wires to a centralized processing system. As you can see in this picture, with so many sensors connected in a large building, this will be very difficult to maintain and install. One more novel method is to use wireless sensor network with centralized data collection. But it is not connected to internet for remote monitoring. Apart from these methods, the latest trend is to use IoT or Internet of Things as smart solution for structural health monitoring. The main advantage of IoT solution is the connectivity to internet. This enables remote monitoring of structures which was not possible in wireless sensor network solution. This solution also enables the cloud computing possibility, which will be useful for data analytics. Apart from these advantages, the IoT solution shares the advantages of WSN solutions such as low cost, easy installation, and accurate data gathering. The use cases of IoT application in structural health monitoring are many. The important one is the possibility to use data analytics through cloud computing. We can use the data from one building or structure to analyze and monitor it completely, or we can use data from multiple buildings and have a combined view of the structural health. This might be useful for private real estate builders or even city planners in cases of natural disasters like earthquakes. The next important use case is the availability of structural health data instantly. Through internet, the real-time data is made available to all the application users. This can save time in executing the corrective measures in case of problems in structures. We will see the technical challenges of structural health monitoring application from IoT and WSN perspective. The two important considerations that has to be taken into account for designing an SHM applications are that sensors in SHM produces large amounts of data that has to be transferred to the central system. This large amount of data should get to the destination with high reliability. There should not be any loss of data while transferring. The other technical challenges include the network should be automatically configurable when deployed. Also, to save energy and create bootstrapping function, the multicast routing should be supported in the network. To ensure reliability of data transfer, multiple routing paths should be supported between the source and destination nodes. Also, the routing protocol followed should be aware of the energy levels of sensors and provide a balanced energy consumption in the network. The typical network topology followed in SHM application would be directed acyclic graph. Also, the network should be scalable. The typical network would be having hundreds of sensors for measuring and routing purposes. The SHM network do not have any particular quality of service requirement other than low latency and reliable data delivery. The network should provide support to verify the data source. Even though the sensor data is public information, the data collected should be from trusted sources. The typical SHM network are deployed from extreme outdoor places to less demanding indoor locations. And SHM network should also be fault tolerant without human intervention except device failure. We will see the physical view or deployment view of an SHM application. Here we have low power sensors at the structure like bridges, buildings and tunnels. These low power sensors operate on small packet sizes and communicate to internet through gateway. The communication from sensor and gateway happens through 6LoWPAN. 6LoWPAN is a protocol which enables IP addressing for each individual nodes. The communication from gateway to internet happens through IPv6 protocol. There are two ways the sensors can communicate through gateway and send the data to the monitoring center. Each individual node can send its own data to the server, or one of the sensor nodes can aggregate the data and send it to the server. The latter example is more power consuming and can be less efficient for a long time. At the monitoring center, we have servers, which will be used for computation, analysis, and provide services to the client applications. These applications will be used by structural engineers and city planners. We will see a real-life example of structural health monitoring application. Here we see an RTMS system or real-time monitoring system. Here we have sensor nodes which collect data from the structures and send to internet or through local notification module. This local notification module can send email on certain events. The data sent through internet is distributed to remote servers. For this purpose, publish or subscribe interface is used. Here we can see a typical client application which shows critical data collected from the structures.
As we know that it is a combination of web services and embedded devices which makes Internet of Things. Web services are built on Internet Protocol, and low power wireless devices are meant for wireless sensor networks. Internet services today rely heavily on web services which mainly use the TCP/IP stack. 6LoWPAN allows to use these services to communicate with these low-powered constrained devices. Wireless sensor networks typically have less bandwidth and shorter data frames, whereas IPv6 or v4 frame size is much larger. Hence, these packets have to be broken into smaller packets to transfer on the low-power networks such as 802.15.4 standard and repacketized for again the applications to work on it. Here we compare the two protocol stacks, the IP protocol stack and the 6LoWPAN protocol stack. They both are all essentially the same. 6LoWPAN maps out the IP protocol stack for low power devices. There is an additional adaptation layer which adapts the IPv6 for low power devices, and this is usually done by the edge routers which are present at the edge of the wireless sensor networks. Now we are going to see a full-scale deployment at the new Carquinez Suspension Bridge, California. The highlights of this project are that it has 28 wireless sensor nodes collecting data over 80 channels. It has a wireless cellular connection to a remote database server. It is based on client-server architecture and the wireless sensor network pushes data into the database server termed SenStore. SenStore is developed by one of the local companies in US. Software clients called as statistical inference tools pull this data and provide it to the structural engineers. The architecture of this bridge management system is quite similar to what we saw earlier. It has a low power network to collect data through the wireless sensor networks and an internet enabled cyber environment to process this data. The cyber environment has a server which provides the data to its client, which can be a modeling tool or a decision making tool or maybe a bridge inspector. The low power wireless network sends its data to a local server or what is called as on-site server, which collects all the data and sends it to the remote database through the client API and the server APIs. Now we are seeing the implementation of the cyber environment of this project. As you can see, here is the Narda server or the bridge, and here is the actual server, the SenStore placed in Sunnyvale, California, and there might be a client who is working in University of Michigan and monitoring all the details of the bridge. This is what IoT brings us on the table. And before concluding, we want to show you a movie clip.
The bridge is gonna collapse. Holy shit, boss! Get on the bus! Come on!
Well, this guy had a premonition of the bridge going to collapse, but in real life you need structural health monitoring. And now we arrive at the conclusions and we will see what are the future directions from here. SHM is a key area for smart object networks. Structures such as buildings, bridges and dams or heavy machinery are all critical for us, and they will be monitored through IoT, and we have seen that IoT is much more effective and efficient. SHM through IoT has big potential and it will be definitely evident in future. We are going to see smart cities which will be made of all these smart structures. We will have repository of structured data and monitoring algorithms to run. IoT is maturing and also wireless sensor networks, and we are going to see a combination of Internet of Things with wireless sensor networks which will produce better solutions and smarter.
Thank you for watching this presentation.
I hope you like this video. Let's build safe structures.